moving on to writing the formulas for ionic compounds. The ionic compounds are going to consist of positive and negative charges that are held together by that strong electrical attractions that are between oppositely charged ions. Okay, and so an example would be sodium chloride, which is table salt, right? Sodium is positive, chloride is negative, so that ionic bond between them is strong, and that's what we're going to learn how to calculate now. So we're going to learn how to use the charge balance, how to write the correct formula for an ionic compound, and how to calculate them. So ionic compounds are going to consist of positive and negative ions. They have an attraction that's called an ionic bond between positively and negatively charged ions. And they have high melting points and they are solid at room temperature. So for ionic bonds, I teach this in my other biochem class too. And this is a very silly way to remember what the bond name is. But if you've ever used a hair dryer and they have like that purple button, it's an ionizing button for reducing static electricity, right? Well, what is electricity? It's a charge. So ionizing ionic bond. So the ionic compounds and therefore the ionic bonds are going to be between positive and negative ions. Opposites attract, right? So if there were two positives, they would repel each other. If there were two negatives, they would repel each other, but opposites attract. So sodium chloride is table salt, one of my favorite spices in the whole entire world, right? And it's more known, more commonly known as salt. The magnification of NaCl crystals or sodium chloride salt crystals shows the arrangements of sodiums with a positive charge and chloride ions with a negative charge in a sodium chloride crystal. So you can see you have the sodium in the purple, chlorine is a gas, right? And then when they are combined, you can see this is how they are actually organized. So the chemical formula is going to represent the symbols and the subscripts in the lowest whole number ratio of the atoms or ions. And so this whole number thing is very important, okay? You can't write fractions of them. So it's like balancing out the reaction so that they're whole numbers. The ionic compounds is such that the sum of ion charges equals 0, okay? Because again, everything wants to be a happy, stable medium. And so it has a charge balance. And so we have to make sure that the total positive charges from, for instance, the sodium equals the total negative charges from the chlorine. And so the sodium is going to lose 1 electron, the chlorine is going to gain 1. So this one's a simple 1-to-1. So we have our sodium, which is 1 positive, plus 1 negative for the negative charge, right? And then the 1 plus minus 1 is going to end up equaling 0, and that would give you the equal charge for sodium chloride. So looking at the subscripts in the formula and how they're all written out, right? When we look at magnesium chloride, okay, magnesium from our handy dandy little table that I just printed out and laminated for us, right? The magnesium is going to be losing 2, where again, the chlorine each is going to gain 1. And so that means that we would have to have 2 chlorines to balance out, because the 2 negatives to balance out the one single 2 plus. And so that's why magnesium chloride ends up being Mg2 or the MgCl2, because it's 1 magnesium that has a positive 2 charge and we need the 2 negative 1 chlorines to balance that out. Okay, so this is what we get to practice today in writing ionic formulas. All right, so going on to sodium sulfide then. Okay, so our sodiums, we know each are going to lose 1 electron, therefore giving it a +1 charge. And then our sulfur, right, or I'm sorry, yeah, our sulfur is going to gain 2 electrons. And so then again, he's an easier one to figure out because we need the sulfur that has a -2, so we need 2 positive ones to equal that guy out, okay? So this is how you get to figure them out. All right, so let's practice. Write the ionic formula for the compound formed with Ba+2 and Cl ions. Okay, so pause me. All right, so the barium right, is the +2, and then the chlorine is -1. So that means that when we balance the charges, we have 1 of the +2, and we have the -1, so that means we need 2 to equal the 2, and then that would end up being a 0. So you have to write the cation first, and then the anion second, and then that would give us the formula of BaCl2. Okay? It's kind of fun once you get it down and practice it. It's like, oh yeah, that's cool. All right, so here's a longer one for you. So again, pause me and come back. Okay, so sodium has a +1 and the oxygen has -2. So we're going to need 2 sodiums to balance the 1 -2 oxygen. So then that would end up giving us the formula of Na2O. For the aluminum, it has +3. Chlorine only has -1, so we'd need the 3 to balance it out, and then that would end up giving us AlCl3. Okay, and then magnesium has a +2 charge. Nitrogen has a -3. Remember, it has to be whole numbers, and so then we're going to give this to 6, right? So we'd need 2 +3s plus 2 -3s, right? To end up giving us 0 because it has to be the negative. So that ends up giving us the number 6. Okay, so very cool. Good job, guys.